So in the previous video, we looked at when the acceleration are constant, so we looked at how to differentiate to go from a displacement to velocity and then to a acceleration function. And so you can see in this illustration here what happens when we go from displacement to velocity to acceleration. But sometimes we might want to go the other way around. So we might be given the acceleration function and then we want to find velocity and then the displacement, in which case we'll do the opposite of differentiation, which would be integration. So you can see here, you're going to have to integrate the acceleration function to get the velocity function, and then we're going to have to integrate the velocity function to get the displacement function. Now, important things to note is when we're integrating, we're going to get this constant, right, plus c, and this c you're going to need to be defined before answering further questions. So we have a particle p moving on the x-axis. At time t seconds, the velocity is given by this here, in the direction of x increasing. At time t0, p is at the origin. In the subsequent motion, p passes through O twice. Find the two non-zero values of t when p passes through O. So we're given the velocity is this function here, 6t squared minus 26t plus 15. And we're asking for when p passes through O. Seeing as to work this out, we need to understand, what's the displacement function, right? And we know to get the displacement, we have to integrate the velocity function. So I'm going to have to integrate this velocity function, 6t squared minus 26t plus 15. With respect to t, so dt, this will give me 2t cubed minus 13t squared plus 15t plus c. Important that you include this plus c. Now, before answering this question, we actually need to find this c, so we're going to be given some information. As you can see here, at time t0, p is at the origin O, i.e. the displacement is 0 as well. So when t is 0, it tells us that s is also equal to 0. Which means if I was to plug it in, then we'll get the c is equal to 0 in this certain case. Right, so now we've got the displacement function. So we've got 2t cubed minus 13t squared plus 15t. They're asking us for when it passes through the origin again, so i.e. when s is 0, so I equate it to 0 and then solve for t. I can take t out, and then if you were to factorize, you get 2t minus 3 and t minus 5. So the two non-zero values of t will be 3 over 2 and 5, like this. The second example, so if a particle p moves on the x-axis, the acceleration of p at time t seconds is given by this. So we're given the acceleration function, which is 4t minus 3. When t is 0, the velocity of the particle p is 4 meters per second in the positive x-axis. When t is capital T, the velocity is 4 meters per second in the positive x direction. Find the value of t. So we're asked to find the velocity, right? So we're given the acceleration. So in order to find the velocity, I'm going to have to integrate this acceleration function. So I'm going to have to integrate 4t minus 3 dt, which will give me 2t squared minus 3t plus c, like so. Now this is, before doing anything else, we need to find the c, right? So luckily we're told that when t is 0, the velocity is 4 meters per second. So I can plug this in. So I can say that 4 is equal to 2 times 0 minus 3 times 0 plus c. So therefore c is going to be 4. So the full velocity equation will be 2t squared minus 3t plus 4, like so. Now we can answer the question. So this says when t is capital T, the velocity is 4. So when is that the case? So we'll say v is 4 is equal to 2. I'm going to replace it with capital T. 2t squared minus 3t plus 4. We'll get 0 is equal to 2t squared minus 3t, which I can factorize. So t with a 2t minus 3. So t is going to be equal to 3 over 2 seconds, like so. Right, let's try another example here. So a particle travels in a straight line such that its acceleration is given by 6t plus 2. So acceleration is 6t plus 2. When t is 2, the displacement is 10 meters. When t is 3, the displacement is 38 meters. So we're given two sets of conditions actually. And they're asking, find the displacement when t is 4. So to find the displacement, we need to find the velocity first, which would be integrating the acceleration function. So we're integrating 6t plus 2 dt. So we're going to get 6t squared over 2, so 3t squared plus 2t plus c. Now we have to find the c, right? But we're not given any conditions regarding velocity, because this, remember, is the velocity function, and all these conditions are regarding displacement. So in order to do that, I'm going to have to find the displacement function first, which means I'll have to integrate the velocity function. So integrating 3t squared plus 2t, and I have to include this plus c as well. Right, so integrating this, I'll get t cubed plus t squared plus, remember c is just a constant, so that's going to be ct plus an extra constant, which I'm going to call d, like this. So this is now my displacement function. Now I can start plugging in the conditions, but they said when t is 2, S, they said, is 10, so I can plug that in. So I'm going to get 10 is equal to 2 cubed plus 2 squared plus 2c plus d. And then simplifying a bit, we'll get that negative 2 is equal to 2c plus d. I'm going to plug in the second condition, so they said that when t is 3, S is 38, so same situation, just plugging it in. 38 is equal to 3 cubed plus 3 squared plus 3c plus d. And if I was to simplify that, I'll get that 2 is equal to 3c plus d. What you notice here is we actually get two equations and we have two unknowns, so I can use simultaneous equations. So we'll get minus 2 is 2c plus d and 2 is 3c plus d. And if I was to do simultaneous equations, then you'll get that c is equal to 4 and d is equal to negative 10. So that's how we're going to go about finding these conditions or these constants. But now they're asking the displacement when t is 4. So the full displacement function s is going to be t cubed plus t squared plus c was 4, right? So 4t minus 10. And they said find the displacement when t is 4. I'm going to plug t is 4 into here, and s hopefully we'll get is 86 meters. Right, part B, the velocity when t is 4. So remember the velocity here, this is the velocity function, right? And we had this plus c, but we found this plus c now. So we can say that velocity is equal to 3t squared plus 2t plus c, which was, remember, 4. And they want us to find that when the t is 4, so plugging in t is 4 into here, and you get that velocity is equal to 60 meters per second here. So you can see that the integration itself is not too difficult, it's just making sure that you find the constants correctly and you know how to link them up together.